So hello everyone. So in the topic of partial differential equations, we are going to discuss about the classification of partial differential equations, because you know partial differential equations are the entire world, because you cannot vary a partial differential equation with real life happenings. Okay, it is the blended scenario, it is a blended idea, because partial differential equations are equations which discuss about rate of change with respect to time, or with respect to some temperature change, or with respect to some other parameter. Multiple parameters can be involved. So here partial differential equations can be classified into two important ideas based on the order and the linearity. Okay, you know partial differential equations or differential equations, whatever it is. Differential equations are derivatives which has first order, second order, third order, even we can go to nth order. We very well know in the basics we were teaching you what is the first order differential equation and ordinary first order differential equation. For example, if you are talking about rate of change of distance, it is called velocity, first order. Rate of change of velocity, we get acceleration, second order. Likewise, to each and every rate of change, the order goes on increasing. Order goes on increasing. According to the calculation, according to the outcomes, everything differs. Now, based on partial differential equation with respect to order, we have first order and second order. Even we have multiple orders. It's based on the scenario situation, how much order required in that area. For example, if we are going to talk about the heat flow in an equation, so we can go maybe second order, maybe you can go for second order equations, we can get solution, because when you talk about heat flow, or when you talk about wave motion, or when you talk about liquid flow, we can use a maximum second order. Because we are going to talk about the momentum, we are going to talk about maybe the electric field, or we are going to talk about the magnetic field or vibration or a kind of continuity in the flow, whatever. We can go for the second order. Suppose if the industry is involved with more derivation areas, we might go with third order, fourth order as much as required. Higher orders we can go. Then again, linearity. We are going to talk about linearity. The differential equation can have two types. It can be linear, it may not be linear. So we call linear and non-linear, that is dependent variable and derivatives appear to the first power, or suppose if the products or powers of the dependent variable or derivatives appear in non-linear form. Likewise, we have two areas. Okay, now suppose if we talk about different types of PDEs, this is a very important concept, because the rate of change in a partial differential equation may not be the same in every scenario. You know the figures, like we have elliptic model, we have parabolic model, we have hyperbolic model, paraboloids, ellipsoid, hyperboloid. We have variety of models are there. And if you take about structural engineering, we have, even if you have seen various recent architectural designs, we have parabolic that is ceilings are there, hyperbolic ceilings are there. So the structure will handle the entire weight by spreading the weight through all these beams. So we have multiple challenges to construct such kind of roofings. So how the engineers work on it? Even we can say, even you can talk about scenarios like it is not the same. The partial differential equations are not the same. Okay, so we have multiple challenges in day-to-day life. So accordingly, the partial differential equation can be classified as elliptic model, parabolic model, hyperbolic model. Okay, here the very important thing is, so where we see elliptic models can be seen in steady-state phenomena, maybe in fluid dynamics, where a steady state flow may be there. Suppose if you take parabolic models, we see in heat equations. Parabolic differential equations are used in heat equations. Suppose if you take hyperbolic models, they are used in wave motions. Okay, so everything is transfer, heat transfer, mass transfer, everything is transfer. See, if you are talking about a wave equation, it is also a transfer. So because wave is transferring, Again, if you talk about water, even whatever fluid you take, it flows. Even it is a transfer. If you take a heat is also flowing from maybe from a lower temperature, higher temperature to lower temperature, heat is flowing. Am I right? But periodic time. Am I right? So here also there is a heat transfer. Is like a kind of flow. So wherever you come across flow or wherever there is a rate of change, so you need mathematics. Without mathematics, nothing can be done. Without mathematics, nothing can be done when you talk about various types of flows like this or very type of industrial areas. Even in computer science, you can think of rate of change, whatever are happening in maybe in memory part, maybe in other arrays part. So rate of change. If you again you want to understand the time delay in your robotic structures, again you need partial differential equation. So again there, if you want to understand the time delay and you have to apply some function, you have to get the rectified and you have to give a solution like this is how the robotic, the humanoids can be made so that the time delay can be reduced. So